I'm Paul. I've been working with software for about a decade now, except for a brief hiatus spent blowing up lots of balloons, which I don't like to talk about. And I realize now, after I've put in my 10,000 hours, give or take, that everything I really needed to know to build software well, I learned over 20 years ago in prison. But that's enough about me. I'm curious, how many people here are currently using the methodology they would describe as Agile? Okay, if you're not using Scrum, put your hands down. How many people are not using Scrum? Okay, good. What are you using? Bingo. And it's working?
Yes.
Cool.
Exactly.
They're wrong. Something's working for them. What else are we using?
We're using the same thing as Kanban.
Cool. You guys gotta do the lightning talk.
Yeah.
How many people have used a lean process or have used Kanban? A couple. Okay, so I expect some harsh questions and some help when I need it. How many of you have heard of Kanban or are familiar with Kanban? Okay, so I think this is an experience report, but I would to spend just a little bit of time on Kanban itself. But first I just want to tell you where I'm coming from so we can see whether or not there's any comparisons in your environment and mine. For the last almost a decade, I've been building web applications. Lots and lots and lots of web apps. So that's the environment I come from. We've got about 100 web apps under our belts, 25 people working on them. We build almost exclusively for startups, mostly offshore development work. Our average team size is just about 4 to 6 people. Our average project is about 3 to 6 months. We don't do a lot of really big stuff, we don't do a lot of really little stuff. And so this is the environment that I'm coming from and that has really colored my thinking about the way in which to implement a software development process. If that's drastically different than yours, you should think very seriously about the validity of my conclusions to your environment. Gotta be closer. There. So, we had gotten really good at building software using Scrum. We've been doing it since 2006 on all of our projects. We've tried deviating from Scrum by the book. We've always gotten burned. I found that we have been able to innovate a bit, and we've developed some good practices that work for us, but every time something goes wrong, it's because we've deviated from the standard best practices of Scrum. But there was one thing that I saw happen, not enough to force me to do anything about it, but enough to recognize an annoying pattern, and it's one I should have known exactly what to do about. If I had paid more attention in my production and manufacturing course, in my MBA program, if I had thought more critically when I read Mary and Tom Poppendieck's first book on lean software development, I would have had the solution to this problem. And this is the problem. Let's say you've got a project. This is your project board. These are the tasks you're planning on doing this iteration. It's a small project. You've got a team of 2 developers, 1 tester. The stories take approximately 2 days to implement. They take about a day to test, and you're doing a 10-day iteration, which is what I found is very comfortable for small web development projects. So on day 1, your 2 developers each grab a story to work on, and they work on it during day 1, and they work on it during day 2. So around day 3, they're ready to hand these things off to testing, to do the manual testing, cross-browser testing, and some of those things that I think we still need human beings for. And your tester gets started on testing, and so on day 3, this is what it looks like. And on day 4, the tester finds a few bugs. The developers are still happily working on their next tasks. On day 5, going into day 5, the tester has found some bugs on the next task. And the developers have now finished what they were working on and start working on these bugs. And then the tester moves on to working on the things that the developers have just finished. So by now you're into about day 6. And the developers have fixed these bugs, and so they're going to grab some new tasks to work on. The tester is going to start, they're going to push those bugs into testing, do regression test it, they start working on some more tasks. I think this is enough of a picture. What we see here is about day 7 or 8 of a 10-day iteration. Has anyone ever seen this before?
Yes.
So what you end up with is a burned down chart that looks something like this. Work is being done. Good people are doing good work that has to be done every day. And then just around here, what you end up with is a whole bunch of finished features, a whole bunch of fixed bugs that have to be rapidly regression tested. Everybody just works really fast and really hard on the last day to try to keep this iteration from being a dismal failure. And in the end, they go to the product owner and they say, look, we almost accomplished all of our goals for this iteration, and don't look at how we did it. But we did it. It's very stressful for the team and for the product owner, and it often leads to a lot of sloppy work at the end. And this was not what I saw all the time, but often enough to be annoying. And so when I started hearing about Kanban for the first time, which was late last year, around October, November, this was my introduction to Kanban. I read these 2 books This is Kanban and Scrum, making the most of both by Henrik Niberg and Matthias Skarin. I haven't met them, so if I mispronounce their names, forgive me. And the other one is Scrumban, a very heavy and interesting book by a gentleman by the name of Corey Lattice. Very, very interesting books, got me interested in the idea. And these are a couple of the blogs that I found useful. And the community, the online community in which most of the most interesting discussions about Kanban are taking place now. There's a lot of other good sources, but these are the ones that initially inspired me. And so, what is Kanban? Essentially, it's a very lightweight process. There's only 3 practices. They are to visualize your workflow, to limit your work in process, and to measure and improve your flow. There are, if you look at the blogs, you'll see up to 7 or 8 practices, but these 3 are always the first 3 no matter who you ask. And the way it looks in practice, this is a Kanban board. This particular team, you can see, has phases of work, the things that they're going to work on next, analysis phase, development, acceptance, and things that have been pushed to production. Other things you can see here is that tasks have one color, defects have another color. The whole idea is to make the board tell as much of a picture as possible, and we've seen all of this before. There's some useful things here I don't see all the time, like the pictures of the people who are working on tasks, which immediately tells you who's doing what, and I think more importantly, how much stuff you've got started that nobody's doing anything with right now. And we can go into a little bit more details about how we've implemented these ideas, but I wanted you to see what it looks like. This is another example of an online Kanban board. Personally, I like the paper. I think that big visible charts on the wall are the best way to communicate in a team room. But I know most of you, certainly my team, does a lot of distributed team development, and so those big charts on the wall are really pretty for everybody except for the people who aren't in the country. So these online tools are a reality for us. Another very useful tool is the cumulative flow diagram. And a quick look at this. This is a cumulative flow diagram for an entire project, a small and short project, but it tells us a lot, and I'm going to show you how to read such a chart. What's happening over here is at the very start of a project, you can see that there are 5 things that are sitting in the backlog with things to be done, and somebody's already grabbed one thing to start working on. So by the end of day one, you've got something in testing, 2 things are being worked on, 5 things are in the backlog, which means that somewhere there's a product owner who's adding more things to the backlog. And the things that you can tell from a diagram like this are the growth of the overall curve shows your scope creep, which isn't necessarily a bad thing. It just shows how much new stuff is being added to the overall project over its life. The vertical height of any of these columns, of any of these areas, shows you exactly how much work is currently being done in that particular phase of the process. The work in process is the height of all of the areas that are involved in actually producing the features. So in this case, it's everything from the time that a developer starts work until the feature is completed. And these can be defined differently by different teams. And then what remains to be done is everything from the backlog to deploy. So you can see all of this at a glance. But you can also see some very useful metrics that give you an idea of how your team is working. Cycle time is a measure of how long it takes to finish something once it's started. That's a simple definition. It's also how long it takes to completely clear your work in process. If you can think of it that way too. It's the amount of time it takes from when something is started until it's finished, and it's very useful to measure the efficiency of the team. And again, on this chart, just by looking at the cycle time over time, you can see that there are places where this team has been more efficient and less efficient in terms of delivery of value. And lastly, lead time, which is a very useful measure that shows how long it takes from the time that something is put into the backlog until it's deployed and a person can actually use it, which I think is a measure that a lot of development teams lose sight of, but it's the one that's first and foremost on the minds of the business owners, the product owners, the people who want to see their requests not just done, but usable. So these are the two basic measures, cycle time and lead time. Cycle time, like I said, is a measure of efficiency of the team. It can be looked at in a number of different ways. Anybody who's familiar with Little's Law knows that there is a correlation between the cycle time, the work in process, and the average time to completion. And that's a very interesting thing to think about, because as a development community, we've been focusing for decades on efficiency, and we're getting really, really, really good at it. In terms of trying to find better ways to get things done faster, automating our testing so that the manual component doesn't take nearly as long or not at all. Better practices just to develop software faster. So if what we're really looking for is the way to get work through faster, there's not a whole lot more we can do on the efficiency of development. But what Little's Law tells us is that there's another factor we can look at too, which is the total amount of work in process can improve our cycle times. And we'll see how that works very shortly. And the lead time, of course, which I already defined, it's how long it takes until a request is actually usable. So let's take a look at how that same scenario might play out using a Kanban approach. Still, 10-day iteration, still 2 developers, still 1 tester, still takes 2 days to develop a feature, still takes about a day to test a feature. There are still bugs that are coming up. But there's something new here, which is these work in process limits. And they're very powerful. What this indicates is that the team has decided that they're not going to work on coding more than 2 features at any one time. And they're not going to work on testing more than 1 feature at a time, which makes a lot of sense because it eliminates task switching and improves the overall efficiency. And let's see what happens. On day 1, the 2 developers grab 2 items. It's important to note that all items are pulled. It's a pull system. You don't say, here, you go do this. You say, this is ready to be done. And when you're ready to do it, it's ready to be pulled. So by day 2, it still looks like this. And then at the end of day 2, the first developer to finish says, this feature is done, and the tester will go and grab it, pull it into his process, and start working on testing. And so on day 3, he finds a few bugs, but we've got a problem already, which is that the other developer has finished his feature too. And he goes to the tester and says, pull this out of my queue, because I can't pull anything into my queue because our work in process limit is reached. And the tester says, no can do, buddy. My working process limit has been reached too. I've got this thing stuck in here because it's got a couple of bugs, so I can't pull it down. So what can the developer do?
Fix the results of bugs.
Well, yeah, exactly. The first instinct is to gripe and sit on their hands. Read all of those blogs that they haven't been following for a while and complain about what a ridiculous process you have. And this is the first big growing pain of implementing Kanban. Because something that you might have noted is that's not the feature that he wrote. And I know that we've known for a long time the importance of collective code ownership, but in practice, developers really don't like fixing somebody else's bugs. And this is all about getting away from the process and looking at what we're trying to accomplish, not just I'm writing code and I'm writing code all day and I'm paid to write code. Everybody on the team is paid to produce value as efficiently as possible. And so getting people excited about the process of producing value is a big step to getting this guy happy to walk over here and say, look at those 2 bugs. If that's what I need to do in order to go back to writing code, then let me look at those. And it turns out that there's a typo and there's a validation error, so they get fixed on day 3 instead of taking on new work. Point. Now look at this. It's day 3, and we already have work done than we had done on day 8 before. And so he goes and grabs a new task. So what you end up with is a burn down chart. It's not much, it might be a little bit more successful. I've made this slightly more successful in terms of the efficiency gains that I've seen from eliminating task switching. But it's much more satisfying. It maintains a much more comfortable pace. And you're delivering value a lot faster. These are all usable features that could be deployed if you were using an iterative deployment process. So, that's what I knew going into it. That's the problem I had. This is what I now knew about Kanban. And I really wanted to try it. We do distributed development, and so I need an online tool, and there was none. So I decided to build this. And I'm not going to go into a lot of detail on this. This is not a product demo. This is the experience that we had going from building that application using Scrum and shifting to Kanban. It took us 6 weeks to get to a working public alpha. And during those 6 weeks, we built it using 3 iterations of 2 weeks each. And then as soon as we had something live and working, we decided that we've just written a Kanban tool. We should probably use it. And this is where it gets interesting, because we had a team of 4 developers here, and we had to first build up our workflow to define the value chain. And as a team, we worked together and came up with this. There's all the stuff in the backlog, and that was just, I think by then I had 75, 100 ideas for things this thing could do. And so in part because of that, we've been using this concept called ready, which is a way of isolating of all of those great ideas, which ones should actually be actioned and which ones are ready to be actioned. Because up until a few years ago, we used to have a lot of problems with tasks finding their way into the backlog without the designs quite done yet, or without something quite well defined. And so we stole from the idea of done, the idea of ready. And everyone on the team has to agree that anything that goes into ready is truly, I can grab this, I can work on it, I don't have to ask anybody for anything. Maybe, of course, the usual discussions that you have, that the developer should have with the product owners, but I could start work on this. In progress, which is features that are being worked on, in testing, features that are being tested, ready for acceptance, which is our last step, where the product owner looks at it and says, yes, that is, I'm happy with the way that works, and then deploy. During the very first iteration, we had to add a few more. We had some new guys on the team, and the discipline of doing code reviews before sending something to testing wasn't in place. So what was happening was sometimes code reviews were happening concurrent with manual testing, and so some bugs that were being found by testers could have been caught earlier by peer code review. So we put a column in place to make it very explicit that after it's done, before it goes to testing, there's a code review, which is another nice thing about using a Kanban board, so you can have your process ready exactly as explicit as you need it to be. We'll probably delete this column when the practice becomes so entrenched that people are doing it automatically. And then we didn't have that nice buffer ready for testing, a place where people could stick things so the tester knew what they could pull. And we were deploying on a daily basis as things were accepted. So we created an accepted column where we could put all those things that were ready to be deployed. And then we needed work in process limits released. So again, as a team, we talked about this. I've seen a lot of advice about how to set work in process limits. Some people say set them high and then work on gradually improving your process, because if you set them too low, it'll turn people off when they start having those issues like the one that I showed you earlier. I've heard that the ideal working process limit is a team size less one. So it forces some collaboration. But this is what we were comfortable with, and that was a working process limit of 5 for ready. So I couldn't ever ask for too much stuff. This is really handy too, because while I think it's important that everybody working on the project have a vision of where the project is going and what it's supposed to be and what problems it solves and who is going to use it, I don't think they have to look at those 200 things in the backlog every single day to figure out what to do. You have to distance yourself to some extent from the context to avoid getting completely mired in it, especially since, in my experience, fully 10 to 30% of everything in the backlog never ever gets done because business requirements change, the environment changes, new ideas come up. And so I'll get into that a little bit later. In progress, we had 4 people, so we set this at 4. And in testing, we had 2 testers, we set this at 2. It seemed comfortable. We didn't set working process limits for ready for acceptance because acceptance is usually a really fast process. And so we ended up with a board that looks like this. And this is the way it looked just a few days ago. So you can see there's 4 things in ready. There's 3 things that are in progress. There wasn't anything ready for a code review or QA at this day. Things tend to move through here really fast. There was 1 task that was in testing and something waiting for acceptance and 1 thing that was ready for deployment. We've been deploying really fast now, so this column tends to stay pretty empty too. And the last thing is reporting. We only recently started putting in some proper reporting measures, measuring our lead cycle time. I thought it was important to get the sense of flow going first so that people weren't too focused on the metrics and could focus more on how they work together and how they collaborate. But you can see for this project, which is now 6 months into it, our average lead time was abysmal. Over the life of the project, 11 days from the time that something was requested until it was live. Cycle time's not so bad though. 3 days from the time the feature is requested until it's ready to deploy. And you'll see why that happened very shortly, and what we can do about it. And here is the cumulative flow diagram for this project from the day that we implemented the cumulative flow diagram functionality, which, as you can see, was the 26th of February. And I have a question for you. If you think about how cumulative flow diagram works, how what we're looking for is consistency in flow, and how what we're trying to avoid is bottlenecks in the system, where here do you think we as a team were most comfortable? Here? 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 This was awful. What we're seeing here is an explosion of work in process. Here is a time when things were going through, and at the end of every day, there was practically nothing nothing in any of the queues. We were just processing your work through and deploying it as fast as we could. Here is where things were going in, and as you can see, we had some times up here when there was a lot of work in process, and sometimes when we had bottlenecks forming and releasing, but we weren't deploying anything. And this represents the time when we decided to migrate the application from Merv to Rails 3. It's supposed to take 2 weeks, it ended up taking a month. We couldn't deploy anything half done because it's not the kind of thing that you can break into minimal marketable features. It was just a week to move everything to Rails 3 and 3 weeks to find all of the bugs in Rails 3 and find workarounds for it. I'm going to show you our deployment history, and I think it tells a story of improvement. Deployed, a month later, a month later, a month later, a month later, and then once we started getting really comfortable with the process, which luckily happened before this conference, this would be pretty I feel silly giving an experience report here when we were still pretty dissatisfied with the process. We're deploying on practically a daily basis now. And it's a great feeling to have a system where value is just constantly coming out the end, flowing smoothly through the process and coming out the end. This is another view. This is a cumulative flow diagram without that shows the value that's been deployed to the live site. It's a bit of an anomaly here. This is when we implemented a feature right here, which allowed people to archive all of the tasks in the done column. And this is when we realized, oh my goodness, our archive tasks are showing up on the cumulative flow diagram. So this is an anomaly. But as you can see here, this shows right there, we've got an explosion of work in ready for development. You see that big chunk of blue right there? That's when we had a delay in deploy. Here, that huge chunk of blue, this is all stuff that's finished, ready for deployment, that hasn't been deployed. That's our Rails 3 migration. But interesting things to look for here are, like up here, you see that big blob of red? Red is ready for acceptance. Guess who took a holiday? Yep, exactly. What you're looking for when you're looking at a chart like this is oftentimes when there's a big block of when there's a column getting full or overfull or more full than usual. Usually it's an indication that you've got a bottleneck forming in the next stage in your workflow. And it's a very early indication of when that's happening, because it happens within hours or days. And I'll show you a few projects where this happened. This is one. These guys were nice enough to let me reveal everything. We started working with Kanban for this project just about a month and a half ago. And this is what the board looked like before I left. What's the problem? Yeah. Everything was going really nicely until just about 3 days ago now. And a bunch of stuff started getting pushed into testing, or pulled into testing, I should say. The team made a decision to overload testing. This is a new team to Kanban. This is not the team that's been doing it for 6 months. This is the one that's been doing Scrum. So this is their first growing pain. And they didn't solve it the way that we solved it before. They didn't solve it by having the team scramble around all helping out testing. There's a lot of ways you can fix this kind of problem. You can see these really dark areas here. Those are blockers. Those are things that are blocking tasks from being able to be pulled forward. They could be skirting around those blockers. Interestingly, both blockers are ready, but not in process. So it's clear what needs to be done, and it's clear that there's a problem. And what they've ended up doing, which they just started before I came here, is one of the developers is testing. They decided that testing had gotten behind because they had had some really difficult functionality to test. So one of the things they're doing is one of the developers is helping the tester to test these features. The other thing they're doing is they're improving their quality control process before it gets to testing. They're doing much more rigorous code reviews, and they've implemented doing hallway tests on every single feature, so that testing has far fewer bugs to find, and things don't sit in testing really as long. So the thing I like about this is not that it solves all problems, but it does exactly what I've been shooting for all along, what we've all been shooting for all along, is to realize problems as soon as possible. No process is going to solve your problems, but the best process is to show you exactly what they are, exactly where they are, as fast as possible so you can do something about them. And this is our cumulative flow diagram, and you can see, let's see, which was the testing? You can see that the problem started right about here. It became obvious about here. And the immediate thing that happened is that it started causing a backup here. So by the next day, you were already seeing a change. The ready for testing had been really small. Things had been flowing through ready for testing really fast, and all of a sudden it triples in size. That's a good indicator that you've got a bottleneck at the next stage in the process. Sorry, I'm trying to go through this pretty quickly because we didn't have a whole lot of time. This is just one that I want to show you. This is a completely different scenario. I can't tell you very much about this because it's a big project, it's very public, and I'm under NDA not to say who it is or who we're working for, what have you. But I was brought on this team. This is the bigger team. It's got 15 people working on it. They're using Scrum, they're deploying monthly. And the scenario before I came on board a month ago was that they were really happy that they had finally started deploying at the end of an iteration and not a day or two late. But deployment day was not a day to hold schedule a retrospective, because on deployment day they were spending a whole day dealing with deployment. It was a disaster. And then they were finding all sorts of issues immediately after deployment. And so there would be 1 or 2 or 3 or 4 patches. In the iteration before I got involved in this project, they deployed on time, and they were very happy with it, but they deployed a patch that night. They deployed another patch the next week, another patch at the end of the following week, and another patch at the end of the next week. So they were 2 weeks into the next iteration, and they were still completely involved in fixing bugs found in last iteration's live code. And they asked me to help. And one of the things that I did to try to see what the problem might be is they were using Redmine for ticket tracking, which is great because it's got all these filters that let you look at only what you want to see and blind yourself to the big picture. So we had a whole development team of developers who had filters set up to show them only the tasks that were assigned to them. So nobody knew how big the backlog was. Nobody knew how many bugs there were. They only knew what they were supposed to be working on today. And so I started taking all of the items out of their tracking system and putting them onto a Kanban board and updating it on a daily basis. And this is what I saw. This is the first iteration that I got involved in. And I started doing this about a week into the iteration. And what do you see happening here? Remember, when the entire chart's going up, that means you've got a growth in the total amount of work in the system. And where is it coming from? It's mostly bugs. And I think most useful is this one on the bottom. This is the cumulative flow diagram only showing the work in process phases. And what you're seeing is an explosion of work in process. Just about a week and a half into the project, getting at its worst about 2 weeks in. And a big chunk of that is that the amount of work that's in progress, the stuff that's being developed, is much larger than the team size. And it turns out that there were a lot of developers who were working on something until they needed a question answered, or working on something until they needed some feedback, and then switching to something else until they got it. And so you'd have a team of 15 people working on 30 things at once. This other thing is this is the stuff that's waiting for customer review and sign-off. And in this case, the customers are rather complex group that is insulating the team from the real business owners beyond them. And so it's not uncommon at all for things that are referred back to the client for approval get kicked back to the team, which is another one of the problems that happen. But the immediate problem is getting that feedback so you know what needs to work before it can be deployed. And it's getting huge here, It's kind of manageable, there's a half dozen things that they need to give feedback on. And it starts getting bigger and bigger as tasks get done. And so right about here, I had a call with the team, and I showed them these charts and I explained what was happening. And they started cracking down. Developers started not taking more work. They started taking more initiative to the answers that they needed in order to finish what they had already started. The client started doing a somewhat better job of approving features that were finished. Testing stayed pretty stable. And so as a result, we did not succeed. But for the first time, we released right on time with only a single maintenance patch that was done on the same day. And so they're converts now. This is just a tool. It's a tool for revealing problems. And I think that the idea of work in processes and limiting work in process and visualizing work in process is a very, very powerful tool, which plays very nicely with Scrum. So, to finish up, I told you what I needed to know about project management in prison. I ran a kitchen crew right out of college because that's all you can do with an undergraduate degree in anthropology and English literature. 30 inmates, murderers, rapists, drug dealers, cooking 3 meals a day for 1,500 people who would kill us if we made a mistake. A meal is late, riot, they kill us. If the meal is cold, riot, they kill us. It's a great incentive. But there's just little me, and I was like 20 years old with all these big guys. And some of the things I learned is the whole process of having 20 people cook 1,500 meals is too big to micromanage. You can't run around and say, okay, you do this. Okay, wait, you do this. Stir those potatoes. So what you need to do is make sure that everybody has a shared vision. Everybody understands what they're supposed to be doing, and they understand what success looks like. It involves making sure that your part is there, your part is there, and your part is there, and these are the deadlines, and everything has to be done, or else they will kill us. So having a shared vision is very important for the team, and trusting the team to pursue that vision. Also making sure that they have the tools and that they understand what their part in the whole process is. So that they know if you don't have 200 gallons of mashed potatoes on that line by 5 o'clock, it will kill us. And if you don't have all of those onions chopped by 4 o'clock, you won't be able to make the stew, and it will kill us. And so making sure that people understand exactly what their component to the big vision is and how their success is going to be measured is essential to giving them the freedom to be able to succeed. Nobody comes to work to please the boss, especially in a prison. They hate the boss. The thing that motivates people most is a sense of accomplishment. They know what their goals are, and they're given the tools and the training that they need to accomplish those goals. They'll be much more inclined to do their very best work. And I think that's true for developers and prisoners alike. Respect. You can't reward a prisoner in any way. You can't give them more food. You can't give them more money. You can't give them a pat on the back. That's illegal, and it might kill you. But what you don't see in prison, what prisoners never get, is a little bit of respect. And a little bit of respect goes a long way in motivating prisoners. They will love you if you give them a little respect. I think there are some parallels with programming, but I don't want you to quote them too deeply. When you do fail and survive, we would have a big meeting, me and all the prisoners, to say, why weren't the mashed potatoes ready? decompose the problem, find out exactly what happened, and how we can fix it. Now, it's amazing to me, when I got started in software development 10 years ago, that was not a standard practice. People didn't think analyzing our failures was an essential component to developing software. I was part of the problem. I spent the first year, the way we dealt with failures 10 years ago in the software process is after we had gotten beyond it, usually by making a lot of apologies or maybe blaming somebody else, then everybody wanted to run away and forget it had happened. And it really took Agile to show us the importance of inspecting and adapting. But this is a lesson I learned in prison 20 years ago, and only now realize I should have been using software all along. And finally, the risk of dying in a riot is a very strong incentive. I haven't figured out how to apply this yet to software development, but I'm working on it. And that's all I've got before lunch. I know we don't have a whole lot of time because this was a pretty compressed presentation. But does anybody have any questions?
Yeah. Why don't you tell us your real reason why you are in prison?
That was just my first job out of college. It's mass. I know some people have very strong opinions about this, but there's also some people who agree with me. The backlog represents an enormous amount of mental energy that is constantly consuming not just the team, but especially the product owner. When the fact is, when we're doing continuous deployment, or almost continuous deployment, deploying daily, and we've got a maximum of 5 things going into the process at any given time. Even if there's 200 things that I want, I don't need to look at that list of 200 things. A person who's really involved and engaged with the business goals behind the project always can answer the question, what's the one next thing you want to see? Which is, assuming that you've gone through your vision exercise and everybody has a shared vision of the ultimate goal, that's all you really need. So one of the things I'm thinking about doing is completely getting rid of the backlog. And maybe just making a text file with a someday maybe list to look for when I need inspiration. But for the most part, just focusing on the next highest value items, which any good product owner already knows. And the other thing I'm doing is putting in place better metrics so that we can get cycle times per estimate size, cycle times per task type.
So with Scrum and approaching a project from nothing with a customer, you can do like the micron estimate size, derive duration, and come up with some number that you can give a customer for like how long the thing's going to take, ergo how much it's going to cost you, right? So how do you do that with Kanban, or do you do that?
I think that's really a question for each and every team, because one of the things that Kanban is not very prescriptive. It says nothing about estimates. It says nothing about iterations. It says nothing about planning meetings. It says nothing about stand-up meetings. My team has chosen, as part of the sales process, to do a release plan. As the start of the sales process, to look at what the customer wants, to estimate the tasks based on the estimation measures that work for us, utilize our historical velocity measures to estimate the current overall size. But one of the things that we never do is, and this probably will lead into the open space topic on fixed time, fixed cost projects, is promise a set price for a set feature set, because the feature set always changes anyway. I think that whole sales process is useful, but most of the results of the process should probably be thrown away, and the primary focus of the team, the moment the contract is signed, should be on building trust, because that's what you really need ultimately in order to create and maintain a satisfied client. Okay, thank you.